I made the two different triangles and I have used simply the Pythagoras rule, that namely the base square plus height square is hypotenuse square. So, if A is the angle as shown in the first triangle and B is the angle shown in the second triangle, then because if you see the expression, you need the value of sin A, cos A, sin B, cos B. So, I have taken sin A as 1 by 3 and with the help of this expression, the value immediately of cos A turns out to be square root 8 by 3 and cos B is 4 by 5. So, in that case sin B is 3 by 5. So, either you take the help of these two triangles and the help of Pythagoras theorem, or you simply apply the identity, that is sin square A plus cos square A is equal to 1. So, given sin A we can easily find out cos A, and similarly given cos B very easily sin B can be found out. So, using these values cos of A plus B, that is cos A cos B minus sin A sin B, write down these value. Cos A is square root 8 by 3 and cos B is 4 by 5 minus sin A which is equal to 1 by 3 and sin B that is 3 by 5, and this is equal to 4 square root 8 upon 15 minus 3 upon 15, and that is 8, because square root 8 you can write square root 4 into 2, but square root 4 is 2. So, 2 will be multiplied by 4. So, that is 8 square root 2 minus 3 upon 15. So, this is the required value of cos of A plus B. Now, here you see A and B I am taking in second quadrant, because in second quadrant sine is positive and tangent is negative. So, you can see from the figure also, I have made the figure, and simply using the Pythagorean rule, I have found out the value of cos A, and then tan B is given. So, cos B and sin B I need, and here you have to be very careful for the signature of these expressions. That is why I have made both the pictures very clearly, because cos A will be minus 3 by 5. Now, here is a remark, because if sin A is equal to 4 by 5 and if we apply that formula sin square A plus cos square A is equal to 1, then the value of cos A will turn out to be 3 by 5 as well as minus 3 by 5, that is plus minus 3 by 5. But because of that restriction on the angles A and B, because A and B are in your second quadrant, you have to be very careful regarding the sign of all these 4 values, out of which 2 are given, means regarding cos A, cos B and sin B. So, cos A will be minus 3 by 5, cos B will be minus 4 by 5, while the angle B is corresponding to the second triangle, while the A is corresponding to the first triangle, and with the help of these two, these 3 values can be obtained, which I have written minus 3 by 5, minus 4 by 5 and 3 by 5 respectively. And now you use your formula, namely sin of A plus B is sin A cos B plus cos A sin B, and the value of these expressions are available now. So, this is 4 by 5 into minus 4 by 5 plus minus 3 by 5 into 3 by 5, and that turns out to be minus 16 by 25 minus 9 by 25, and that is merely minus 25 upon 25, which is equal to minus 1. So, again I gave the stress upon one thing, that the choice of A and B, where it is given like this, that will determine ultimately the sign of the corresponding values of sin and A cos B, sin B, cos B, etc. So, you have to be very careful regarding finding out the values of these expressions. Now, here also once again the angle are of same nature, sin A is 4 by 5, tan B is minus 3 by 4. Of course, you have to merely change the formula. Last time you had sin of A plus B, but this time it is cos of A plus B, which is equal to cos A cos B minus sin A sin B, and of course, in this case it turns out to be 12 by 15 minus 12 by 15, which is 0 by 25, which is precisely. Now, let us see these formulas corresponding to tangent. Now, I have taken this simplest approach by finding out the formula for sin of alpha plus beta and cos of alpha plus beta. So, using these two formulas, I have tried to evaluate the expression for tan of alpha plus beta, but the independent proof also you can give as you gave in the case of cos of alpha minus beta, because the first proof I have proved only basically one thing, that is cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta, and all the formulas which I have derived, they are simple consequences of this one particular formula. So, using all those four formulas which I wrote as a summary, the four formulas, namely for sin alpha plus beta, cos alpha plus beta, sin alpha minus beta, cos alpha minus beta, we can derive the formulas for tan alpha plus beta, tan alpha minus beta, cot alpha plus beta and cot alpha minus beta. So, the very first thing which comes in your strike in your mind, that tan of theta, if you want to use the expression for sine and cosine, so immediately you should write it as sin theta upon cos theta. Therefore, tangent of alpha plus beta is sin of alpha plus beta upon cos of alpha plus beta, because I want to use the expressions which are available for sin alpha plus beta as well as for cos alpha plus beta. So, this turns out to be sin alpha cos beta plus cos alpha sin beta upon cos alpha cos beta minus sin alpha sin beta. Now, you will say, well, why I am dividing it by cos alpha cos beta, the numerator as well as the denominator? Because it is always convenient, because in the sense that the expression for tangent of alpha plus beta, I would like to have it in terms of tangent alpha and tangent beta. So, if I divide numerator and denominator by cos alpha cos beta, then of course I get tan alpha plus beta is sin alpha cos beta upon cos alpha cos beta plus cos alpha sin beta upon cos alpha cos beta, then divided by cos alpha cos beta upon cos alpha cos beta minus sin alpha sin beta upon cos alpha cos beta, and I use the fact that sin theta upon cos theta is equal to tan theta, and immediately I get this value tan of alpha plus beta is sin alpha upon cos alpha plus sin beta upon cos beta, 1 minus sin alpha sin beta upon cos alpha cos beta, and this can be written in terms of tan as tangent of alpha plus beta is tan alpha plus tan beta upon 1 minus tan alpha tan beta. And the formula for tangent of alpha minus beta, you could have taken it as sin alpha minus beta upon cos of alpha minus beta. That is also the correct approach, and repeat the same process which I did in the case of tangent of alpha plus beta, and you might have got this expression. But here I am using just for simple fact that beta you replace by minus beta, then tangent of alpha minus beta is merely tan alpha minus tan beta upon 1 plus tan alpha tan beta. So, these expressions means for tangent alpha plus beta or tangent alpha minus beta, they could have been obtained by separate independent method also. There in first formula I have taken the help of two expressions, namely sin alpha plus beta upon cos of alpha plus beta. Here I could have taken in tangent of alpha minus beta case as sin alpha minus beta upon cos of alpha minus beta, and by dividing numerator and denominator by cos alpha cos beta, I might have got, or rather I will get the same expression which I have merely obtained replacing beta by minus beta. So, next lecture I will continue this discussion, and I will give some applications also. Thank you.